Hello everyone. In this part of lecture, I am going to discuss some numerical example, MCQ based from the basic electrical engineering book Nagrath and Kothari. So let us start. This is problem number 1.10. And in this problem, it is given that 8 volt is appearing across this 4 ohm resistance, 8 volt. So we have to find the value of this source voltage. What is the value of this source voltage? So see here, 8 volt is here and 4 ohm resistance is here. So what will be the current in this resistance 4 ohm? Just using Ohm's law, I equal to 8 by 4. Voltage by resistance means 2 ampere. 2 ampere is current flowing here. So same current will flow here also because these two are connected in series. So 2 ampere current is flowing here. So what will be the voltage here? So voltage will be here 2 multiplied by 2 Ohm's law. Current multiplied by resistance means 4 volt. So 4 volt is here, positive sign is here, negative sign is here. So positive to negative, positive, then positive to negative, again positive. So 4 volt and 8 volt is here. So this voltage Vs source volt will be equal to 8 volt plus 4 volt equal to 12 volt. So your option will be C. C is the correct option. Come to the next point, next problem. In this problem, we have to find the value of Is, means this source current we have to calculate. What is the value of this source current? Here 2 ampere current is flowing, it is given. So now what will be the voltage across this element? Again use Ohm's law, V equal to I into R. I is 2, R is 2. So 2 multiplied by 2, it will be 4 volt. 4 volt is here and this resistance are connected in parallel. So voltage across this element and this element will be same, means 4 volt is here. So voltage is known, so we can find out the current here. I1, let it be I1. So what will be the value of I1? Voltage is how much here? Voltage is 4 volt. So 4 divided by 4, it will be 1 ampere. So 1 ampere current is going here and 2 ampere current is going here. So source current, applying Kirchhoff current law, Is will be I1 plus 2. Meaning 1 plus 2, it will be 3 ampere. So this option C is the correct answer. Now come to this is very interesting problem. So come to this point. Let us see here for the circuit, for the series RC circuit shown in figure 1.12, the voltage VR across resistance. Means we have to find the voltage this VR for the resistance having for the resistor having resistance 1 ohm. Here the voltage is given as sine t across the capacitor. So voltage is here time dependent, so we have to apply the rule for current in the capacitor, which is equal to IC equal to C dV by dt, and C is 1 and D voltage across the capacitor is sine t and divided by dt, so it will be cos t. So cos t is the current flowing in this capacitor. So same current will flow also this resistor because these are connected in series. So we have the known value of current in the capacitor and as well as current in this resistor because both are connected in series. So current is known and here resistance is known. So what will be the voltage in the resistor? VR will be the current IC multiplied by the value of resistance, which is equal to 1. And IC is cos t. So cos t multiplied by 1, it will remain as cos t. So our option is B is the correct option here. Now we come to the, this is very interesting problem in a GATE exam. This is a GATE type of question. So now come in the another example. Here it is given current flowing in the inductor is sine t and we have to find this whole voltage from here to here. It is required to calculate. So let us see the equation for the voltage across the inductor. Current is sine t here, sine t will be flowing also here. So here also in this, because these are connected in series. So sine t will be also flowing here. So in this inductor, we have to find first voltage. So we know that the voltage in the inductor is L di by dt. L di by dt. What is L? L is 1 and di is sine t divided by dt, differentiation. So sine differentiation is cos, so it is cos t. Means here voltage is equal to how much? Cos t, cosine of t. And here current is flowing. How much? Sin t. Sin t current is flowing in here, and sin t current is also flowing here. So what will be the value of voltage here? So sin t multiplied by 1. So voltage will be sin t here, and here voltage is cos t. So we have to add it, sin t plus cos t. Total voltage will be sin t plus cos t, and we have to solve it for sin t and cos t. So it is, suppose here 1 is given here, and here again 1 is also given here. So we have to solve it by squaring and adding, like rule we have to follow. So 1 divided by root 2 into sin t plus 1 divided by root 2 into cos t. So, and multiply it by root 2 also, so that this relation and this relation is same. Now you see that the option which is multiplied by root 2, which option is? So this option will be the answer. So let us see how we solve it. So this is how much? So this is just a mathematical relation. We have to follow this mathematical relation here. So multiplying 2 and dividing by root 2, and we know that 1 by root 2 is cos pi by 4. So I'm just writing here cos pi by 4, and here cos t is same, and 1 by root 2 is also sin pi by 4. So this formula we will get it like that. It will be equal to root 2 multiplied by sin t plus pi by 4, means sin a plus b formula is used here. So correct option is option number 4, not option number 2. It is, so it is correct option is 4. Now we come another example, that is here we have to find Vs, and here 1 volt is given. So in this case we will also find the value of the voltage across this. So here current is how much? 1 volt is there, 1 ohm is there. So current in this resistor will be I equal to, from Ohm's law, voltage divided by resistance, 1 divided by 1, it will be equal to 1. So 1 ampere current is flowing here, same current will flow here. So what will be the voltage here? So here voltage will be V equal to 1 multiplied by 1, means 1 volt. So 1 volt is here and 1 volt is here. So if we add these two from here to here, the voltage will be 2 volt. From here to here, the voltage will be, you will get here, from here to here, the voltage will be 2 volt. And this 2 volt is also same for this resistor. So what will be the value of current here? Let it be I2. So what is the value of I2? I2 will be this 2 divided by 2, voltage divided by resistance. So this is equal to 1 ampere. So now total current is how much? You see here, 1 ampere current is going here, and similarly, and same way 1 ampere current is also flowing here. So what will be the flow of current from here? Current flow from here will be 2 ampere. So 1 ampere here, 1 ampere here. So here current will be 2 ampere. So what will be the voltage across this 2 ohm resistance? You check, tell me what will be the value for this. Here current is 2 ampere. So voltage in this resistor will be 2 volt. 2 multiplied by 1 means 2 volt. So Vs we have to find voltage. So if we consider this closed loop from here to here, closed loop from here to here, so this voltage plus this voltage will be equal to Vs. So this 2 volt plus 2 volt, so Vs will be 2 plus 2 means 4 volt. So our option C is correct option. Now we come to the another problem. This problem is, here we have in the circuit figure itna V is, what is the value of this V is? In the question this V is asked, what is the value of this voltage V? So let us see here, it is 4 ampere here, current is coming in this part. So we have to break this current in two parts, here I1 and here I2. Division of current rule we have to apply. So I2 will be equal to, this current is, suppose it is I, so this current I multiplied by this resistance in parallel resistance 2 and divided by whole resistance 2 plus, this is 1 plus 1, this is will be 2, because this current has to be divided into this 2 ohm and these 1 ohm and 1 ohm. So these branch 1 plus 1 ohm is in parallel with this 2 ohm. If you draw this diagram like this, it will be like this. So you see here it is 2 ohm and it is also 2 ohm and this is 4 ampere. So by virtue of the question, we can directly say that this current will be equal to. So we have to calculate the current division, current in this 2 ohm resistance. So what directly you can say that 4 ampere current is coming and these are two equal resistances. So definitely 2 ampere current will go here and 2 ampere current will go here. If you apply this formula, you will also get the same result. So I is here 4 multiplied by 2 divided by 4. So 4 is 4 cancelled. So 2 ampere current will be flowing here. So 2 ampere current is flowing here. So 1 ohm resistance also have 2 ampere current and this also have 2 ampere current. So what will be the voltage here? Resistance is 1 and current is 2. So voltage will be equal to V equal to 2 multiplied by 1. So it will be 2 volt. So correct option is B. Now we see one more problem, which is also very interesting. There is one more problem, 1.16. 5 ampere current is coming here. 10 ampere current is also coming to this node. And I1 is flowing here and I2 is flowing here. So in question, it is MCQ question also, and I1, I2 value we have to find out. So let us see using the Kirchhoff current law, all the current, sum of the current at any junction is 0. So this current 10 ampere is coming and 5 ampere is coming. Let us see, let us take it negative and outgoing current take as positive. So I1 plus I2 plus minus 10 minus 5 will be equal to 0. So from here we will get I1 plus I2 equal to 15 ampere. So we have with 2 unknowns, so we need 2 equations. So another equation, we will see here, these and these are connected in parallel. So voltage across this element and across this element must be same. So voltage we are applying here, voltage rule, I1 3 multiplied by I1 equal to 5 multiplied by I2. Because this voltage and this voltage are same. So 3 into I1 equal to 5 into I2. This is equation number 2 and this is equation number 1. So we can solve this equation 1 and 2 and from here we will get the value of, from here we can put I1. I1 will be 5 by 3 I2. I1 equal to 5 by 3 I2 and putting this value in this equation from here. So I1 is 5 by 3 I2 plus I2 equal to 15. Just solve it. 3, 8 and it will be equal to 45. So you can solve this equation for I1 and I2. So we will get the value of, or no, this is not 5, this is 6. Actually, this is 6. That is why. So it will be 6 by 3. So it will be 2I2. So it is 2I2. So here we have to put 2I2 plus I2 means 3I2. So I2 will be equal to 5 ampere. 15 divided by 3, it will be 5. And just we put the value of here, here I2, 6 multiplied by 5, it will be 30. So 3 multiplied by I1 equal to 6 into how much? 5. This value is not 5, it is 6. So it will be coming, I1 will be coming 10 ampere. So I1 is 10 and I2 is how much? 5 ampere. This is the correct option, which is in the question. It is the correct option is option number A, 10 ampere and 5 ampere. Okay, thank you for watching this video. We will meet next some new problem in the next video.